The last topic is intermediate value theorem. Before stating the theorem here, let me start with quite interesting question. So this is the globe. Suppose we can measure precise temperature at places on the globe. The question is, can you find a pair of places with the same temperature at the same time? Can you pick two places with precisely the same temperature at the moment? Well, the point is we can prove this using continuity. Well, the answer is yes. The idea is to pick a path from North Pole to South Pole. So pick a path from north to south. So say you are taking some plane to follow a path like this. And then you can measure precise temperature along this path. So measure and then record the temperature along the path. Then you can draw the graph of the behavior of temperature along the path. So suppose we have North Pole and South Pole. Well, the temperature is quite low, but eventually the temperature will increase and then decrease like this. So suppose the graph of temperature looks like this. Again, the question is, can you find a pair of places with the same temperature? Yes, the answer is yes. Well, once you draw horizontal line like this, things become clear. Say this is your temperature. Look at this, place A, place B. You can find the temperature so that two places have exactly the same temperature. Okay, so bottom line is continuity. We are assuming the graph of this temperature is continuous. Then you can find the temperature so that two places have exactly the same temperature like this. That's the idea of intermediate value theorem. Suppose you have continuous function. So this condition is not negotiable. Continuity is very important. If you have continuous function on closed interval, say from A to B, like this. So we have continuous function defined on this closed interval, from A to B. Say the graph looks like this. And we have two values, f of A and f of B. So then you can pick any number n between those two. So say your number n is somewhere here. Then you draw horizontal line. Then you can find number c inside this closed interval so that f of c is exactly n. That's it. So for any number n between f of a and f of b, there exists at least one number c so that f of c is exactly n. And this comes from the continuity of f defined on closed interval from A to B.